Okay, problem 3 about Dr. Walker being abducted by aliens who take him to their home and release him on the surface of their planet. And I'm not really joking. This would probably be one of the first things he would think of to do, is figure out what G is. If he has a stopwatch or something, he could do that pretty easily. So he's Dr. Walker. He's that smart. So he throws the rock straight upwards, and it's got some initial velocity, v naught. Okay, so there it is. And it goes up, and then it reaches a maximum height, and it has a final velocity. When it gets to its maximum height, it has a velocity of 0. And then, of course, it comes back down. And boom, there we go. And that's the end. So the total time for this whole thing is delta t, which is given. So, and we're also given the maximum height. So that's actually everything we need to know here. And there are a bunch of ways to do this one, really. Probably the simplest one is to say, if you understand that neglecting air resistance, and we are neglecting air resistance, even if I didn't say so, neglecting air resistance, that the rock will reach its maximum height halfway through the trajectory. So really, if we just look at this and say, well, it took half of this 4.50 seconds to go from here to here, and at the end it had a speed of 0, and this is a velocity v naught, and that was the height, then that's good enough. So let us plug in a couple of K keys, and we will figure this out. So the first, let's see. So the first, let's do V1, or I'll just do V equals V naught plus AT. Okay. And this is, of course, with this being the positive y direction, and our acceleration is negative g, so our acceleration goes downward. Okay, so at the top here, we say 0 equals v naught minus g times t. Okay, so the time it's taken to go up here. And then we can also do a displacement. So delta y equals v naught t plus 1/2 at squared, which of course then means you go up h, v naught, that's v naught t minus 1/2 gt squared. So now let's take, basically we have this equation here and this one, and we've got to solve these two for, well, so we can solve it for g and for, what's the other one? Must be v naught. Which one do we care about? Well, we care about g, right? So let's get this into an expression of v naught in terms of g and t, and then we can plug that in to this guy and get h equals, so v naught is gt, and then you multiply that by t, so you get gt squared, and then this is going to be minus 1/2 gt squared, and so h equals 1/2 gt squared, or we want to solve this for g, right? So g is going to be equal to 2h over t squared. Now let's be clear here. This t is half the total time of flight. So this t here is 1/2 of total flight time. Okay, it's because we were doing all this based on this thing over here, right? And you can do this. There are other ways to do this. In fact, arguably better ways to do this. But so you could do one with the whole flight and use these two equations. You would plug in different things for the final condition, but when you solved them, you would eventually come out to the same answer here, accounting for the fact that it's a different t you're talking about. So anyway, with the numbers we've got, this is going to be g equals 2 times 30 meters, okay, over 4.5 seconds squared. Sorry, whole thing squared, which is going to be, oh, I don't know. Let me just do it in my head. Ignore these other noises you hear. Doing it in my head, doing it in my head. 2 times 30 divided by 4.5 squared. That's the caret 2. Oh, I do my powers in my head using carets. Okay, 2.96. Oh, but I forgot. Oh, okay. So, see, I screwed up now because this is not 4.5. This should be 2.25 seconds squared. Ow, what the hell is that? Okay, I just discovered something new this tablet can do, and it, wow, okay. Well, everything just got bigger, but you can still see it. So, so let's see. Let's take that all and multiply by 4, and then we get, that's what I remember. Okay, so 11.9 roughly meters per second squared is G on this alien planet.